Hi, let's solve the second question from today's bi-weekly contest, that is mark elements on array by performing queries. So let us first understand the question. So basically here we are given a zero indexed array nums, right, consisting of positive integers. Then we are given a 2D queries array also, right, of size m, where each queries of I is going to represent a vector of 2 length, where we will be having first value as an index and second value as in k. Before we look at what index and k basically represent, we are also told that initially all elements of the array are unmarked. Right now, while performing these q queries on the array in order, right, they have told you in order, you have to focus on this. What you have to do is, you have to, on the ith query, you have to mark the elements. Right now, what elements will you mark in the array, that is mentioned in the query. So first index is given, right? So mark whatever is at the index, that particular index in the array. Right now, these indexes are going to be from 0 only. Then what does this k represent? Now mark the k unmarked elements in the array with the smallest values. Basically take the smallest values of the array and start marking them. And how many values will you mark? K values, right? So let me show you what you have to do. See, what this query basically represents is, this is an index, right, and this is what? K. So index means mark whatever is present at this index. So let us say I represent marking with an underline. So I'll go to this index, right? Let me also index these elements, right? So I have to mark the value at one index. So I'll mark this 2. Then what I have to do, I have to take this k smallest elements from this array, right? So we are being told to take two smallest elements, right? So the first smallest element I can see is present here. The second smallest number is present at this 3 index, right? You can also see here, they have told you here as well, right? They have told you that these are the two smallest values that you mark using k, and this is 2 basically, which you have marked after taking the first element, that is the index, right? So this is what this query represents. Right now, what you have to do is, basically you have to form an answer array, right? Inside of answer array, its length should also be equal to your query's length, right? So here you have 3 queries, you have to return a vector or array of size 3 here for this case, right? So performing for each and every query, you have to fill the answer. So what will you fill at the answer? You have to fill the sum of unmarked elements in the array after the ith query. So after this particular query, you can see what is the sum, right? So the sum is going to be 8, correct? So you have to fill 8 here. Then for the next query. Now, another thing here is that after you have marked an element, right? After you have marked elements after a particular query, you cannot like consider for the next query your array from the scratch, right? You cannot do that. You have to consider these marked as well, right? And then perform the next query. So for 3 comma 3, these 3 elements have already been marked. All right, so for this, let us perform this. 3 basically means index, go on to the third index. Okay, it's already marked, doesn't matter. If it was not marked, so we would have marked it. Now take 3 smallest values, right? So the first smallest value I can see is present here, right? Then take the next smallest value, which is this particular 2. Then so 2 we have considered, third smallest value, this is the 2, right? So you have to mark these. So I've marked them. Now what is the remaining value? This 3, correct? This 3 we have not marked yet. So only this element is unmarked, so the sum is going to be 3 only. All right, after this query, just go here, right? Go here and perform for this. So for 4 index, right? See, 4 index has already been marked. All right, move ahead. For this 2, right? Consider 2 smallest elements. Now the smallest element are less than 2. So they have also told you if the elements become less than k, right? So you have to mark all of them, right? Whatever are the remaining numbers which are smallest. So we will mark 3. Now, what is the sum of unmarked elements in this array? 0, right? So this is how you have to form your answer array. So I hope the question is clear to you, what you have to do. Alright, now let us go ahead and see how to solve this question. Now this question, if you obviously try to do using brute force, the constraints will not allow you to do so. So you have to like consider a optimal approach. But for this question, it's more of an implementation question than of a logic question, right? So let us see how this is a implementation question. So before we discuss how it is an implementation question, simply first thing that you should realize is what you have to use here, right? If you figured out you have to use a min heap here, then this question is completely of implementation, right? So let us see the idea to use a min heap is that in each and every query you are considering k smallest elements, correct? So you have to have the order always sorted. So how can you have the order always sorted in an optimal manner? So obviously you use a minimum priority queue or min heap in that case, right? So that is the reason we are going to take a min heap. All right, now let us discuss how like we are going to approach this question, right? So I'll quickly show you a dry run of the approach, right? Or the algorithm. See, first we have to do a few things, right? We have to declare a sum variable in which we will be calculating before performing queries. I'm telling you what we have to do. We have to do some um, preparations, you can say, right? So let us do those preparations. First, consider an integer sum, right? Now inside of this sum you will be storing the sum of your whole array. So in this case the sum is going to be 12. Now why are you going to consider a sum? See, each time we are marking an element, right, what we can do is initially all the elements are unmarked, right? So we are going to have sum as this. After marking the elements from this sum only I can uh, decrease those elements, right, or subtract those elements which are given in my queries and are I am told to mark them, right? So marking an element means that inside of my answer that sum is not going to be included of the marked elements. So while performing the queries, if I have the overall sum, I don't have to go and after marking the elements calculate the sum again, because I know for each and every query, right, after performing each and every query I know my elements whichever have been marked, they are definitely not going to be included in my answer for the next query, and similarly for the next query. So obviously makes sense to have sum already sorted out. All right, so declare a sum already calculated. Then we are going to make a visited array here, right? So this visited array is going to basically represent the marked elements. Now the catch here is that you have to like keep track of all the elements which are visited, right, and only mark the elements which are not visited. Now for these indexes it's pretty much sorted out what you have to like do, but for these k elements you might be repeating some elements which are already marked in previous queries, right? So you have to consider which elements were they, right, and only mark an element if it is unmarked, right? Alright, so this visited array is going to be a boolean array, and it is going to have the same size as that of nums, and all the values initially in it will be false because initially we have not marked any element. Alright, so here we have 7 elements, right? So alright, all these values initially are false. Then here only we will also create our min heap before we perform any of the queries, right? So now inside of min heap, let us name our min priority queue or min heap as pq, right? Now inside of this, how are we going to store the value? See, index here are of immense importance to us, right? So inside of our min heap, while removing an element, I need to check is it unmarked or not, right? Because I have to mark it, right? After I basically remove from the priority queue, that means I have to mark that element also, that I have like removed it from the priority queue. Otherwise, I might get a wrong answer. So to like fix that, inside of priority queue, I can store a pair, right? Inside of that pair, here I'll be storing the nums of ith element, and with it I'll be storing the index, right? So let me create the priority queue here. Like after creating the priority queue, let us see what will look like. So first all the smallest values will be here. So 1 is the smallest, right? So first the 0th index will be here. and then we have 3, and then what we have 1 comma 6, right? So for 1 we are done. For 2, let us make, so for 2 1, then we will be having 2 comma 2, and then 2 comma 4, and then 3 comma 5. So this is how, like, this is what my priority key is going to look like after I'll create it, right? Okay, so I hope up to here whatever preparations we are going to do is clear to you. Now let us see what we are going to do. We are now going to iterate for the queries, right? So while iterating for the queries, I have to get this index and this k. So what I'll do is, let me, like, let's say q is that query that I'm considering. So for this query, I have to take this index, right? So index is going to be q of 0th element, and I have to take k also, right? How many elements from the priority queue you have to remove? So it is simply going to be 2 in this case, right, which is q of 1 right now, because we have only 2 elements inside of each and every query, so I can like write it like this. All right, after writing like this, I know one thing for sure, that I have to mark this element, right, this. So also, like, this is where visited array is going to be handy for us, right? If let's say I didn't have visited, right, so here you saw that after the first operation, right, you had already visited the third index, and here you are again visiting the third index. So from your sum you will be removing this third index value twice, so which is going to give you wrong answer, right? So this is why you need to have visited. So you have to remove your values from sum also, correct? So you will only remove the values from sum if that particular value has not already been visited. All right, so now what you'll do is, see here, um, you have index, right, q of 0, q of 1. Here what you'll do is, you will simply check if this value is visited or not. So you can see that right now the index is not visited. So what you'll do inside of your visited, you will mark this as true, that okay, now I've visited, and also remove it from your sum. So if you remove it from your sum, what will you get? You will remove 2, right? So you'll get 10. All right, then consider removing k. So k here is what? 2. Now you will be going and iterating in your priority queue, and what you will be doing is, you'll be having a while loop, check until the priority queue is like empty or not. If it is empty, there's no use to like iterate, and also up to k minus minus, that is k should be greater than 0, only then you'll be iterating. All right, now let us start iterating. So we have 2, so you will first remove, so your top element of the priority queue is here, you will remove this element. Now while you remove this element, remember you have to mark the index here as like true in the visited array. So this particular index, right, is here, so you will mark this as true, correct? After you mark this as true, continue iteration. So also, like, it was already unmarked, right? So you have to remove it from your sum, so you'll get 9 here. All right, because now k is not equal to like 0 here, right? So remove another element. So k is 1, right? So you'll remove this element. Now after you remove this element, mark this as visited, and you are going to do this only if this has not been visited, right? So you have to check from your visited array for each and every time, like when you are removing your elements from the priority queue, as well as you are like marking this particular index that is given as the first element in the query. All right, so here it was unmarked, so remove it from your array. Basically, mark visited as true, right? So where is it? It is the third index, so this index you will mark it as true. And also from the sum, because this was unmarked, from the sum, like subtract this 1, right, the first value from this element of the pair, correct? So you will get 8. Now see, for the first query you are done, right? So include it in your answer. So now your answer looks like 8 is going to be here. Okay, go and perform the next query. Check if this index is already marked, right? So you can see it is already marked. Don't do anything, right? Move on to your next thing, that is k. So k is now 3. All right, k is 3. So we'll start removing our elements from the priority queue. Now before we remove, you have to check at this particular index, is this index visited? So you can see that this index is not visited. All right, so what you have to do, you have to remove this index, right? Basically mark this as true and remove this from your priority queue, and also subtract from your sum this first value, correct? So now you will get what? 7. All right. Keep performing the iterations. You have k is equal to 3. Now it will become 2. So come to the next element of priority queue. Check if this one index has been visited. Oh yes, it has been visited. So what you will do is you will remove this element because it has already been visited, and move on to the next element without subtracting anything from your sum or marking anything in your visited array because it's already visited. All right, come to this element. Right, k will also not be decremented in this case if you are not considering this element. This is already visited, right? So you cannot consider this. So k will not be decremented in this case. Then what you will do is you will come here, right? Next top element of your priority queue, 2 comma 2. Now check if this 2 element is visited. No, right? So what you will do, mark this as true, also decrement your k to 1, and also remove this value from your sum. So what you will get? You will get 5. All right, also remove this element. Move on to the next element. Check if this is already visited. So it's not visited, right? 4 index is not visited. So first mark the 4th index as visited. Make this true. Then what you have to do, decrement your k as well as remove this part from your sum. So you'll get 3, right? And also remove this from your priority queue. Now here you can see that k has been become 0. So you have like performed whatever you had to perform in this query. Now include this sum in your answer. So you'll include 3 in your answer. All right, keep moving ahead. Now when you will come to this query, so fourth index is already visited, so you will do nothing here. Now what you have to do is you have to perform for this 2, right? So now k will become 2. So remove 2 elements from your priority queue. All right, so here you only have 1. So as it is mentioned in the question, like you are also iterating until the priority queue doesn't become empty. So if the elements to be removed are less than k, so remove all of them, right? So we only have 1 element, so remove it. Is first of all, but check, is it already visited? No, this is not visited. So go ahead and visit this element. Go ahead and visit it. Make it true. All right. Then you have to do what? Then you have to decrement your sum or subtract this value from your sum. So as you do that, you will get 0, and also remove this from your priority queue. Now your priority queue is like empty. So obviously you will be exiting this particular loop, and so basically like you are done with this query also. Okay. So you have to now include it in your answer, right? Whatever is stored in sum. So now you can see that you have formed your answer, and now you can safely return it here, right? Now using this try run, I hope like what we are trying to do is clear to you, right? So we are basically declaring this sum, and we are, while we are marking elements, we are removing that element from the sum also, because we want to print the unmarked array element sum, correct? Then we are also keeping track of the visited elements or the marked elements, and we are using a priority queue to remove k smallest elements from the priority queue, right? All right, now I hope the approach is clear, right? The algorithm is clear. Now let us go ahead and see the code for it. So here you can see I have declared sum. This is the size of the array. And I have declared a min heap here, right? So in C++, you must be aware that while declaring min heap, you have to pass these two parameters also to convert it to min heap, because by default, your priority queue is max priority queue in C++. If you just declare using the value that you're going to put in your priority queue, right? But if you want to make it min, you have to pass these two also. Okay, priority queue has been declared. Here we are forming the priority queue and also calculating the sum of the whole array. Then we are taking this vector ans, which we have to return, right, our answer array, and we are also taking this boolean visited array where we are simply keeping track of the marked elements. Then we are iterating for the queue queries. As I said, take the index. So q of 0 is the index, k is the like k smallest elements you have to remove, so that variable is k. Then you are checking, right, for the index, right? If it is not marked, only then you will remove it from your sum. So that is the significance of having the visited array, right? So you don't remove a particular element twice from the visited array, or sorry, from the sum, right? So make this true as well as remove it from your sum only if it is unmarked. If it is marked, obviously it's already removed from the sum, right? And then iterate in this while loop and keeps checking until priority queue is empty and your k exists, right? Basically, you are removing k elements from your priority queue, right? So we are taking the min element each time by taking the top element of the priority queue and remove it. You have to remove it. If it is marked, unmarked, doesn't matter. You have to remove it. But you have to decrement k only if you are taking an unmarked value. All right. Okay. So if the element is unmarked, right, simply check min dot, see, the second element, as I said, is the index, right? Here, see, the first element is the value of the element and the second one is going to be the index, right? All right, so min element dot second basically represents the index. So check if it is unmarked. Okay, mark it as true, also remove it from your sum and also decrement your k. And after you will be done with this while loop, either you will be consuming k values from priority queue or your priority queue will become empty before you consume k values. So in any case, you are going to exit from this loop, and after this you can safely say that for this particular query I have exhausted both the values, that is the index and the k smallest elements, and I can safely include my sum in my answer, right? The answer for that particular query. And after this you can simply return your answer, right? So I hope now the question is completely clear. Talking about the time complexity, you can clearly see that you are, see, the major time complexity is going to be because of the priority queue. So it is going to be n log n because of this part, right? Because pushing any element in your priority queue is going to take log n time complexity, and this is like n, like linear time, right? You're iterating in the array, so it collectively it becomes n log n. After that you are iterating in queue queries and you are just removing k elements, right? So that is not going to be a lot, right? So I guess the solution is clear now. So space complexity, obviously you're using the priority queue, so big O of n is going to be your space. You're also taking the visited array, so it will be big O of n. So time complexity is big O of n log n and space complexity is big O of n.